The recorder's on. It's recording the right screen. All right. So I'm trying to do you guys a favor by putting a clock here. So that way, the actual time is recorded, which also means, from here on, if you want to jot down just the time of the day, it's easy for you guys to kind of quickly search through the video to land on the spot that you want. Which also means, recording the time when I start to talk about a new topic or something that's important is going to be helpful, okay? Because the recorder, actually record the actual time as we go, okay? It takes up a little bit of the space of the screen, not too much, but that's okay. All right. So I did a bunch of stuff over the weekend. This is my job, but for better or for worse, it's also my hobby, which is disturbing in some way, but probably good in some other way. Okay. So that's why spend the weekend to work on a few things. Okay. The first one is on the module that we were on, which is the Boolean operator. I was originally using ChatGPT to try to generate some question sets, and that did not turn out very well. Okay, in other words, I was not able to convince it to use the format that I want, and also having certain restrictions on the what expressions that I want to use. So I just go like, oh, okay. Instead of struggling with ChatGPT to get the output that I want, I just spent the time to write the code to generate what I wanted. So that's basically how these questions are all generated. I just wrote the script to do it. So just click it, it'll give you the truth table. And there are, I think, 20 of these or 17. I cannot remember. If you guys want more, I can always generate even more. If you want something that has 4 or 5 or 6 variables, it'll be easy for me to do that. Okay. But the whole point of all of these things is really just for you to spot check that you understand how it works. That's all. Okay. Now, for some people, it depends on the person. The way that I study in college and now is I understand the fundamentals and I have a pretty good grasp of the concept. I only do something like this to confirm that my understanding is correct. So if I make a truth table and it's different from the correct answer, then I go like, okay, I'm not understanding something. Okay, what is it that I'm not understanding? And then I'll try to diagnose my own understanding or where I'm not understanding, and then I'll attempt again, okay, with a different question, just to make sure that I'm getting everything right, okay. But I don't do this, just you know, uh, the whole concept of practice makes perfect does not make sense to me. Okay, I have to understand the fundamental. I cannot just do a bunch of exercises and go like, okay, I have done all of this, I'm good. Okay, I feel good about that. Nope, I have to. There's a certain internal mechanism that I can tell whether I'm understanding a concept or not. But the best way to double check is to compare that to the actual answer. Yes, which one? The first one? This one? Well, none of them makes any sense. They're just randomly generated. So there's no such thing as making sense or not. It's just a matter of is it syntactically correct or not. The truth table does not make sense. Okay, let's take a look at this. I like questions like that because either my question generating program is wrong or there's another explanation. I like to find explanations of things. So let's go. All right. So which row does not make sense? Okay, let's go through this and quickly rule out the ones that are definitely correct. Because there's a and p here, so that means if p is false, the whole thing has to be false. So the first 4 rows, they're all done. Okay. So the only question has to be about the last 4 rows over here. So which one do you want to ask about? Yes. This one, the one that the mouse cursor is on. All right, so I think this one has to do with the positioning of where P, Q, and R are located. This one is corresponding to P, and P is right here. So P is true already. We know one side of the conjunction is already true. So the only other thing we need to check is what is Q implies R. Q is false, R is also false. False implies false is true. So then we have true on the left hand side of the conjunction. We have true on the right hand side of the conjunction. True and true is okay. Here we go. Yep. 0, 1, 1, 0. 0, 1, 1. I mean, this row here? What about it? Oh, I don't even have to go that far. If P is false, then the right hand side of the conjunction is already false. The conjunction is false. I don't even care about what is Q or R or whatever is on the other side. Yeah, the ordering of the letters are different here compared to here. Yes. Rewrite which expression? Yes. Well, there are quite a few ways to rewrite it. Just the implication can be seen as not Q or R. Yeah, just that side. You can also use distribution, which we haven't talked about yet. Okay, so if you apply Boolean algebra, then you can rewrite it in a whole bunch of other ways, but we are not quite there yet. Yes. Okay, you have to speak up a little bit. Okay, so name which one and we can find it. Okay, so let's look for that. So not R blah blah blah. Okay, we'll try to find that one. So are we done with this one before we proceed to talk about another one? We good? Okay, we got a few thumbs up. Okay, so we'll proceed to the other one that was mentioned. I think you're talking about this one. Okay, all right. Well, let's not disclose the answer first, or what I think is the answer, or what my script thinks is the answer. Okay, because that's all it is. Okay, I did not actually manually check every single one by hand. All right, so let's look at this one and figure out the truth table by hand. Okay, whenever P is true, the answer is going to be true, right? Because there's an or over here, and with or, if at least one side is true, the whole thing is going to be true. So the first four rows has to be, I mean, the four rows where P is true has to be true, which I think is the bottom four rows. So the only question would be about the first four rows, because on the first four row we have to rely on the negation of the whole equivalency between R and Q. Question? You look at the parentheses. That's why there are so many parentheses here, because the parentheses tells you exactly what the ordering are between the operators. So you don't even have to understand the priority of the operators, like which one takes precedence, because the parentheses will tell you everything that you need to understand the ordering of when to evaluate which operator. Yes. Color highlight the column and the term. Hmm. Oh, you mean to highlight the column instead of the row? Yeah, yeah. Highlight by the column to the same. Oh, okay. I see what you mean. So this will be colored the same as this, and this would be colored the same as this. This would be colored the same as this. I have to look it up to see whether LaTeX allows coloring, each individual character. If I can incorporate that into the script, it's not too much of a problem. I wouldn't do it by hand though. I mean, yes, VI can search and destroy or search and replace, but it's still some work, some additional work that I normally don't have to do. So, yeah, that could be helpful. Okay. But do you have any question about which row that you want me to address? The last four row is easy. Okay. So any question has to be about the first four rows. Okay. So the actual question is about how to evaluate the operators. Okay. So let me do this. Okay. So I'm gonna have to handwrite this first because otherwise I cannot remember what the expression looks like. And there we go. So this one is the negation open open R equivalent to Q close 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 or P. Okay. So let me switch to the tablet view, which is there. Okay, there we go. And let me erase something that does not should not be there. Okay, so that's the expression. So you use the parentheses. Okay, we all know how to read parentheses. So that means the or is the last operator. Okay, or requires a left hand side and a right hand side. The right hand side is easy, it's just P. The left hand side is the negation of something. It's negating the equivalency between the R and the Q. That's the structure of the expression. Is that okay? Yes. Um, because I'm guessing that you are referencing to these. So the first one is to close the Q. The second one is to close the equivalence, and the third one is to close the negation. It helps if you have an editor that can kind of help you match parentheses. Yes, so there are, basically R and Q do not require parentheses because they're not really sub-expressions, but I'm using parentheses to make sure that everything is has a little container, so visually you can tell which one contains which one. Is that okay? All right. So yes, so parentheses or extra parentheses in this case is basically how we can determine the ordering of what operator to evaluate at which point. Is that okay? All right. Okay, any other questions about the exercise questions that I kind of generated? Does anyone want more of those just in case? No? This is enough already? It is a little painful, and that's why I would only use these to kind of spot check, whether my understanding is correct or not. I'm not going to do every single one of these. As you might have noticed, I didn't ask you guys to turn in anything, right? Alrighty. And if anyone is interested in the script that I use to generate all these questions, I can kind of let you guys, see the script too. Alrighty. Any other questions about, these particular ones? No. Okay. Alrighty. Negated and um negated and negated or are kind of embedded sort of here. Like this is a negated or, but I don't use NAND as a single operator in this class. It's not a very intuitive one even for me. Um, but here's a NAND right here. Yep. But as a single operator, it's just not very natural to us. So we're not going to use that as a single operator. Hmm. All right. Excellent questions. Okay, I don't see any additional questions. So we are going to go back and finish up the last operator, which is equivalence. Okay, this is the last operator that we need to talk about. And by definition, x is equivalent to y is defined as x implies y and y implies x. Because This operator is also known as IFF, which represents if and only if. Okay, so if and only if the if goes this way, the if is if x then y, only if basically goes the opposite way, because x only if y would be the arrow going from right to left. Okay, so if and only if basically means we just have a conjunction of these two, which is basically saying x and y are the same. Okay, because if you look at the truth table, when x and y are both zeros, the answer is a one. When they're both ones, the answer is a one. When they're different, the answer is a zero. You can also look at this as the opposite of exclusive or. Okay, but we don't talk about exclusive or as a single operator in this context. Exclusive or is far more useful in CISP 310, which is the assembly programming slash computer architecture class. In this class, exclusive or is not quite as commonly used, so we don't usually talk about it. All right, but that's it. That's this way we finish up the entire module over here. I changed the homepage a little bit here because I also included a link to a lecture recording on YouTube. I just did it this morning, so if you don't see it earlier, that's it's not because you overlooked something, it's because I have not put the link up there yet. Okay, so this is also a quick and easy way for you to get to YouTube. Go to all the videos, and they are sorted in a reversed order, which means the most recent video is appearing first. So if you want to go back in time, sometimes you might have to kind of page back a little bit. All right. So with all this said, you know, I'm hoping that some of you have started to read the now deprecated, pages, which is okay. Okay, you did not waste your time because even though just this morning I deprecated boop, 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 like three of these things, they're still useful. Okay, because the new one, which is supposed to replace the deprecated one, is from my perspective done, but from your perspective, it's probably still not done yet. Okay, so that means I'm going to extend it a little bit more with examples. Okay, because I know examples are important. Um, all right, so I'm going to get started with this one here, the one that is going to replace the other three. But if you have read the other three, it is still okay. Okay, they're still consistent, they're still correct. It is just that, things are a little bit too verbose in some way, in my perspective, from my perspective. All right, so we'll talk about this one a little bit here. And why do you think I put hair splitting in parentheses, mathematical, close parentheses here? Because it's a bunch of math, a lot of symbols, right? A lot of symbols, and why do we do that in this class? Tech, are you intentionally trying to make this class as hard as it possibly can? No, because if that was the case, I would have used some other ways to make it as difficult as it possibly can be. For those of you who have taken my classes, you know that that probably is possible, but why? Yes. Mm-hmm. Yep. So what That is correct. Okay, so it's very foundational. And what is one thing that differentiates between a more mathematical treatment of something versus a more quote unquote intuitive way to treatment of something? Question? Yeah. Any? Yep. Go ahead. Hmm? You can prove it, and the mathematical way typically involves more use of symbols. Okay, mathematical symbols of all kinds, it's structured in a certain way. Okay, and why do you think mathematicians like to use mathematical symbols instead of just, I'm just going to describe everything using whatever native language that person uses? Yes. Mm, okay, so the one proposal is visuals are more easy to understand. That is only until you're familiar with the symbols. The first time you see those symbols is like, what is this, right? Yeah, go ahead. Gatekeeping and job security. I like that answer. Okay. When I wrote my dissertation, I made sure that I wrote it in a way that, that is only appropriate for a dissertation. So I don't use simple words. Search and destroy all simple words. Replace with unnecessarily difficult and absurd words. Yes. Okay. So that means it seems to imply conciseness and just being concise and to the point. Yep. And go ahead. That is correct. Okay, so math is the foundation of a lot of STEM field, particularly computer science, because computer science is really applied math. Okay, now I know some people do not like it. Okay, do not like the fact that this is actually applied to your math, but it really is. We cannot change what computer science really is. Yes, go ahead. Okay. Okay, so we use the term variables a lot, in mathematical notation because we need to designate whatever is taking this space, that thing, that value is also the same value over here and also here and over here. Okay, that's the use of variable because otherwise we have to say, yeah, that value that we talked about earlier, which one? We have three values that we have talked about earlier. You know, that one with a squiggly line or whatever. That's not a very precise way to say that specific value. So the use of variable is for us to clearly indicate which value are we referencing. Okay, so they're all important. They're all very good points. But the bottom line is, guess what? Programming languages is also symbolic. This is no different than learning, quote unquote, a new programming language. Okay, and if some people are thinking, well, but why do we have to learn a new programming language? I know C++ already, and that should be enough for everything. Nope. The first moment you try to apply for a job and you look at a job application, there are very few jobs these days that require you to understand C++. So you might think, CISP 360, 400, and 430. Is that a waste of time? Well, not in terms of the concept. Okay, a lot of the concepts that you learn in those classes are still applicable. But when you go out for a job, okay, when you try to look for a job, I would imagine at that time there will be another easily five new programming languages that you expected to know that you were never taught anywhere in the four-year university, let alone the two. Okay, so the programming language is just a language, just as mathematical notations is just a language. Okay, once you use it and use it often, then you're gonna get a hang of it. Okay. All right. So with that all said, because I think it is important to understand why I stick with mathematical notations whenever I can, not only in this class. Okay. When I wrote my dissertation, since we mentioned dissertation a little bit earlier, I was using all mathematical notations and all technical rigid proofs in the dissertation. When it was done the first time, when I thought it was done, it was 60 pages, which is really, really short for a PhD dissertation because most are in, what, 100, 200 pages is considered about normal. 300 pages is about the right size, the right, thickness of those things. Mine was only 60 something pages because it's all mathematical symbols. I don't have to explain something verbally. It's just like, yep, it's all here. When they call it when my advisors, okay, the committee, consisting of three professors, when they first read the whole thing, they came back to me almost right away and said, "Tech, you have to use English." That was their comment. Then I go like, but this is all very extremely clear, okay? The proofs are really step by step, and they're extremely clear because of the use of the notations. They did not want to spend the time to read the whole thing. So then I asked, where should I put all the proofs? Where should I put all these symbolic proofs? They go like, well, maybe put them into the appendix. Then I go like, So 90% of my entire dissertation is in the appendix. So eventually, we figure out a way to fluff up the dissertation, so it had about 120 pages or something like that. For anyone who's curious about what I'm talking about, you can actually read my dissertation. Um, I think it's on my personal page, which you can access using the class schedule. So if you go to the class schedule, I'm not trying to get you guys to read the whole dissertation, but I'm trying to get you guys to understand what I mean when I say, oh, there's a lot of mathematical notations. Too much for professors at a four-year university, UC Davis. It's not like they cannot read it. It's just that they don't want to spend the time to read it. So I think it is here on my personal page, right there. So the dissertation is actually a hyperlink. And the topic of my dissertation actually, in a very slight way, relate to one of the topics that we are going to talk about in this class. So we are going to talk about the A star algorithm eventually at the end of this semester. And this particular dissertation talks about a generalization of the problem that A star is trying to solve. Okay, it's a very simple generalization, but as it turns out at the time, nobody actually spent too much time to think about the generalization. So this one does, kind of, my dissertation is basically just, you know, uh, it's about the proof of the properties of a solution, once you generalize, basically admissible heuristic search. So anyway, don't try to read the whole thing, just kind of skim through it and just, kind of get the idea of what I mean by a lot of mathematical notation. I'm just going to scroll to one particular page here. Yep, that's a lot of mathematical notation. Trust me, when I read this again, because when UC Davis contacted me and go like, oh, there's a way for us to publish your dissertation online. Will you give us permission to do it? I go like, yeah, sure. So I got curious about, what my own dissertation was about because there was so many years after that. And when I was reading through this, I go like, wow, that's a lot of mathematical notation. Even I cannot remember most of it. Yep. So it's kind of interesting that way. Okay, so I'm gonna close this now that you guys know how to find it. If you're curious, you can go find it. If you're not, not a problem. Anyway, so we get back to the notation here. But the thing about these notations, now if you go read my dissertation, a lot of those notations is, okay, these are only specific to tax dissertation. I don't ever need to know this stuff ever again if I'm not interested in tax research. And that's back in 1995. Okay, so that's like 30 years ago. Okay, but the notation that we use here, they are common. In other words, you will find these notations in pseudocode algorithms, which also means, oh, so that means sometimes if you need to implement an algorithm, you need to be able to understand these notations in the pseudocode of the algorithm. Is that okay? All right. And these are fairly common, which means they're kind of global. All mathematicians and computer science people actually use these notations too. All right, so we'll go, get started. I try to put boxes around the important stuff that is being defined. So that's what those rectangular boxes are about. They are basically trying to get your attention. It's like, okay, this bullet point is about this notation here. Okay, the one that is in the box. So we'll get started with the very first one, which is the essential one, to understand what is a set. Okay, so in a set notation or in set notations, A, this is it looks like a little E thing, which is element of. So A, lowercase a, is an element of X, is exactly what I said here. It's a Boolean operator, which means A may be, if A really is an element of the set X, then it will evaluate to true. If not, it evaluates to false. Okay, it is just a relation thing. So I know that is awfully abstract. Okay, so let me try to use a concrete example to illustrate it. Okay, so let's just say that you're looking for a file, okay, in your file system, and you go like, I don't remember where I put it. Okay, so and also assume that well, a GUI works too. So you navigate to a particular folder, let's say documents, backslash, um, spring 2025, okay, this semester. And they're trying to say, okay, I thought I created a file called, cisp440.doc, okay, somewhere in the file system. So you go to that folder. The folder is the set. In other words, a set is a container. It can contain stuff, okay? And the file or the file name that you're looking for is equivalent to this lowercase a over here. It is a particular value that you're looking for. And in this case, the question is that file, cisp440.doc, is it in the folder, basically your documents folder? So the answer is yes, it is here, or no, it's not. Therefore, it is a Boolean operator. Okay, it returns a value that is Boolean. Are we doing okay so far with this concept? A set is a container. What can it contain? Well, just about anything other than itself. Okay, so a set cannot contain itself, just like a folder cannot contain itself. Okay, are we good so far? All right. So this is just a symbol. It is just asking the question, is lowercase a in X, which is a set. X is a container. It is a set. All right, the next one, I don't really have to say anything about. It is just equivalency, so we'll kind of skip that one. We'll move on to the third bullet point. As a predicate, P of A, I'm using P as the name of the predicate, and A is the parameter that we pass to the predicate, is essentially a function. In this case, I'm using function in the context of C and C++. I hope you guys still remember what a function is. Does anyone want me to explain what a function is in C and C++? Because I'm just going to mention one thing, which is go back to reread your notes from CISP 360. So that's basically just a function, but it returns a Boolean type. In other words, a predicate is really just a function that returns a Boolean value. A is just a parameter, and whatever P is just going to evaluate some kind of a Boolean expression and returns either true or false. It's a placeholder. Okay, P of A is a placeholder of an expression that somehow involves the use of the value of A, and it comes back with an answer of either true or false. It's a placeholder. Okay, the reason why we need a placeholder like this is the next one. Okay, so the next one goes back to something that's a little bit more foundational. Okay, this one is for all, which is also known as a universal quantifier. So this is basically saying for every value E, P of E is true. That's what the statement is saying. Okay. So you guys go like, but what is P of E? What is the predicate P in this case? We don't know. It's a placeholder. Okay. Because the point of this definition, which is the fourth point from the top, is really just to define the symbol of for all E. I don't care what P of E is, okay? Yeah, because I just need to explain the quantifier, the universal quantifier for all. Yes. So we'll get to that, okay? So that's a good question because what you're implying is for all what, okay? What are we looking at when we say for all? Because for all is the same thing as every for every value E. So what is every here? Okay, what is included in this every? Yep, every possible value. Okay, it contains all the integers, all the real numbers, all the fractions, all the complex numbers, all the matrices that are possible. Me, Professor Iraj, ARC, and so on and so forth. Okay, everything. Okay, in the entire universe is part of this every here. Okay, then you go like, but that makes it kind of useless, right? Because most of the time, why do we care about every? So we'll talk about the mechanism to filter and say, you know what? We want to focus our attention to only these things. Okay, everything that is not part of these, we'll just kind of ignore. There's a way to express that. We'll just ignore everything that is not these. Yep. I do not. I'm not familiar enough with Python to know what is the all function. Mm, it is, in a sense, like a gigantic conjunction across every single possible element. But we'll just kind of leave it like this, okay? The only thing, the first thing you need to remember is when you see this symbol, which is the inverted A symbol here, it just means every, okay? Whatever P of E is has to be true for everything, okay, in the entire universe, okay? And then the opposing one, okay, the counterpart to this, I can actually zoom in a little bit so that the symbols look a little bit bigger, okay? So the counterpart to the universal quantifier, which is what the inverted A is the existential quantifier. So the existential quantifier means at least one. So this means, this if the for all means, for every value E, then the other one says, there's at least one value E such that P of E is true. So out of the entire universe, out of all the things that are possible, I just need to find at least one to make P of E true for the entire statement, the quantified statement, which is this part here, to be true. Okay, so one thing that is kind of useful is to think of the for all as a gigantic conjunction expression and then look at the existential quantifier as a gigantic disjunction. Because in the disjunction, if only one thing of the entire disjunction is true, the whole disjunction is going to be true. That applies to the existential quantifier. And for the universal quantifier, everything has to be true in order for the quantified expression to be true. So basically, it is a gigantic conjunction. Yes. hmm Yeah. You can re-express a like a search algorithm as an existential statement because you just need it to occur at least once. Okay. Very good. All right. So I see that most of you are taking notes. That's good. Okay. Excellent. And then there are some of you who are not taking notes. I do not know the reason why you're not taking notes. Okay, maybe this is all kind of review material to you, which is okay. I know that happens sometimes, but I just want to re-emphasize the importance of taking notes. Can somebody remind me why it is important to take notes? Go ahead. It's a little pessimistic that way, but yes, it can lead to problems down the line. Okay. Yes, go ahead. hmm So the it so it depends on the person, but what you said is right. Okay, taking notes is a way to stay focused on the topic being discussed. Okay, that wasn't the reason why I took notes when I was a student. If you ask me honestly, Tag, do you ever go back and read your own notes after the class? The honest answer is a no. Okay, but that's me. Okay, I have a good friend who is a scientist, engineer, and mathematician, all three, working at the Liver, Lawrence Livermore National Lab, okay, as a lead scientist, engineer, mathematician to solve your really complex problems. He had to take notes meticulously and then go back not only to review the notes, he has to go back and revise the notes. He has to kind of add more stuff to it and say, okay, this concept relates to that concept, and and this is my new understanding of these concepts and so on, because he is dyslexic. I'm not. And I am driven by curiosity. So that's why, I took notes, because, I have to kind of stay focused. Otherwise, I would be kind of distracted easily in the class, okay, and, move my attention to something else. But once I understand something, typically it sticks with me. So I don't really have a need to review my notes, over time. But he had to review his notes. Now, if you ask me, who is who probably has a higher IQ, I think he is at least 30 points higher than mine because I can barely talk to him. They say that if the IQ of two people are off by more than 30 points, they will have problems communicating because the way they think is different. So the way they formulate words would also be different. And that's why, there's a range of, plus and minus 30 point of your own IQ. You can communicate effectively with those people. But once it's more than 30 points away, it becomes difficult to communicate with those people. All right. All right. Just a little tidbits, that I collected over time. Okay. All right. So the original point was taking notes and the importance of taking notes. But Tag, you're recording everything already. I don't need to write anything down. Well, I'm not a mind reader. I cannot read your minds. So when you make a connection between the concepts, or you think, the way tech explains this kind of sucks. I kind of understand it, but I think I have a better way to explain it to myself. Write that down, right? Because when you're reading your own notes, you go like, oh, okay, I understand my own way of explaining this concept. So those are all the reasons to take notes. And I can see some people are still not taking notes. It's okay. It's not my grade. Yeah. I mean, eventually, that's kind of something that all professors need to do is to kind of think it that way because otherwise we'll all go insane. Cuckoo. Yep. All right. So now that we have talked about, are there any questions at all about the universal quantifier versus the existential quantifier? When you use the English word every, you're using which one? Universal. And every time you say at least one, which is most people do not say that. If you say some, that is existential. Okay. So if you want to say every professor at ARC is great, then you're using the universal quantifier. When you say, well, but tech teaches at ARC too, and it kind of sucks. So then you have to say, at least one professor at ARC sucks. That would be the existential quantifier. Is that okay? Okay, so because I want to relate the mathematical notation to something that you use normally in just any normal conversation. And this is nothing it has nothing to do with English because almost every single language has universal versus existential quantifier. So when you write your notes, you can kind of write it and say, oh, it's the same as this word here or this phrase here in my native tongue. All right, shall we move on? Okay. So the next one here, okay, because you can see how the box is highlighting what the bullet point is trying to explain. So this one is trying to explain what is an intersection. Okay, so now we're starting to get into the thing of, oh, okay, so what is the whole thing saying? This is saying for every possible value in the entire universe, okay, that thing, okay, if you focus on just one thing, of the entire universe, that thing is a part, is an element of the intersection between the set x and the set y, if and only if this is also true. So this part here says E has to be found in x and E has to be found in y. That is the intersection. Or that's the mathematical notation of intersection. So I'm going to switch to a more intuitive way to look at intersection. And this is called a Venn diagram. And most people start with a Venn diagram, but I want to start with something that's more fundamental and then go back to the Venn diagram only after I have talked about that. Okay, with power up. Okay, there we go. All right. So if you use this to represent x, this to represent y, and most people use kind of like these things to kind of indicate what is in which one. Okay, so if you look at a set like a kind of like a circle or ellipse here, and you look at y as a set also the same way, then this area kind of in between, okay, let me highlight which area. And since I'll be using this again, I'm going to use a cool feature to add a new layer. and select this new layer. Okay, so now I can say the intersection is this portion here. This is the intersection because that portion is found in X, is also found in Y. Is that okay? So I know this is probably an easier way for most people to understand what is in an intersection because it just goes like, oh, okay, it's the overlap of the two circles. Okay, okay, that's cool. But at the same time, I still want you guys to relate that picture back to the more symbolic definition of an intersection. In other words, I don't want people just to remember the picture, but not to pay attention to the symbolic definition because the symbolic definition will, having more exposure to the symbolic, expression helps you, understand additional symbolic expressions quicker and more accurately in the future. Okay, is that okay so far? All right. So now we go back to the picture, and or before we go back, we'll talk about the union. Okay, so you can see the intersection. It's kind of like a cap, which is also the name of the LaTeX symbol to define intersection. Union is more like a cup, which is also the LaTeX representation to make that symbol. It looks like a U, but it's not really a U. It's a union. So we look at the definition of this, okay, if and only if. So typically, if and only if is used in this context to mean that uh, that this is a definitive statement, which means by definition, this quantified expression is true. Okay, so we are not evaluating whether it is true. This definition is true because it is by definition. So that's what the word definitive is used in this context. So you can see where we had, and here. Now we have a or, which means E can be found in X or E can be found in Y. If it is in at least one, then it is considered to be in the union. All right. So now we go back to the graphical representation to take a look at what does it mean to be in a union. So I'm going to go back to the layer here, and I'm going to erase layer two. Okay, so select it, and oh, we can hide it. Cool. So we just hide it. Add a new layer for the conjunction. Okay, so we'll get to layer three, and this time I will use a shading thing to shade what is in the union. So the union would be everything under X and under Y. Yeah, I know. That's why I don't get a high grade in art, back in elementary school because I can't really feel things to the border. But I think you guys get the idea. Okay, anything that is in X or in Y is part of the union of X and Y. Are we good so far? Okay. So now we kind of go back to the symbolic definition here, and now we move on to the difference. Okay, I know it looks like subtraction, but it's not exactly subtraction. Okay, it is a difference. So this time we are looking at things that are in X but not in Y. Okay. In other words, the word and, which is conjunction, the other word that mean basically the same thing is but, B-U-T in English. So the word but is actually, in terms of logic, is the same thing as the word and, but it is implying the other one, the other thing is contrasting the first thing here. Okay, but in mathematical sense, there's nothing so-called, contrasting. But in this case, we can say, E, anything that is inside the difference between X and Y has to be found in X, but not in Y. Is that okay? So just from the logical perspective, are we understanding what is the difference between set X and set Y in this notation? Okay, all right. So if we go back to the picture, the pictorial thing, now we add yet another layer. Okay, so we'll hide this one and add yet another one. So the difference, if I were to use the shade, okay, I'm still using the shade tool, it'll be just everything here. Okay, I just thought of a good way to explain this. Okay, and you can write it down because I think this helps you understand, what it means to have a difference. Is it is everything in X after Y takes a bite out of X. Does that make sense to you? You just have to remember the Apple logo. Somebody took a bite out of that thing. So Y took a bite out of X. What is left is the difference. Hmm? Or a bit. A bit is one binary digit, a nibble is four, a byte is eight, and so on. So it depends on whether Steve took a bite or Wozniak took a bite. Mhm. There should be two bites out of the apple, but Wozniak never got a chance because Jobs just go like, "I'm taking a bite and I'm hiding it. There's no apple." That's what he did. That's what he did to Wozniak. That's an even better one. X is Wozniak, Y is Jobs. Yep, I like that. Okay, so that makes it easier to remember, right? Because you're associating a story, which is historically true, in order to remember. Ah, so that's what difference is when we talk about set notations. Cool. All right, so we get back to here, and now we talk about some Boolean thing. Okay, basically this is an operator that returns a value that is either true or false. Okay, so this is once again definitive. Um, oh, actually, I think I messed up the definition here. Okay, let me fix it. Let me show you how I can fix this. So it is my bad, I have to admit. Let me go fix it. So some of you have used this feature already in one of my other class, but if you want to make corrections, you can always contribute. All it takes is that you have an account with GitHub, and then then you can look at this all stuff here, which is kind of like, what is all this stuff here? So what I need to fix is subset of, which is here. Okay, so what I intended to do was I didn't quite do it right. Okay, so that's the bottom line. So I need to take all this and put it inside here. And I need one more pair of parentheses around all this. Okay, we have to take out this one. We don't need that anymore. So I have to now take a look at, oh, okay, forget about this. Okay, that ends that parentheses, that ends that one, that ends that one. The next one is off too, so I may as well fix that too. And I do apologize for not checking my notes and kind of not getting this fixed. So we'll take this chunk out and then we'll paste that in and then add another pair of parentheses here, or we just take out the one that we don't need here. Yep, and this one is not ended either. Okay, double checking everything. Okay, we need to, E is in that subset if and only if that's the correct expression, matching all the parentheses, and there exists E that is not in X. Okay, and that's an extra parentheses that I don't need. Take that out. I think that should fix everything. All right, so I need to commit the changes. All right, everything will be rendered. Give it a minute or so. It's gonna have to rebake everything. Yep, go ahead. Mm, intersection. That is correct. Yep, yep. Only the intersection part is actually important. That is correct. Yep. 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 Okay, which one are we referencing? The difference? Uh-huh. Um, well, the quantified expression says, this is how we define the symbol of x minus y. An element is in the difference if and only if that particular value is in x but not in y. So that is how we define, what does it mean to be in an element in the difference? Not exactly, because there's no actual operator of the set that we are talking about here. But what you said is correct. Okay, a little bit earlier, you can also define difference as x minus the intersection between x and y. Let me go to the tablet so I can actually write it here. So you can say that x minus y. Oops, that's not the right font. Let me go back to the right tool. This one here. So you can say that x minus y is also can be seen as x. Um, oh, there's no way to exclude, so we can't actually do that. No, but we cannot exclude. We cannot take a byte out. So there's no way to actually define it this way either. Yep. Say again? Yeah, but we cannot use the definition itself to define itself. So there's no other way to define what subtraction or what the difference operator does using other set notations. So it's one of the fundamental notations that we actually need in order to do this. So I'm going to refresh the page now because the changes that I made earlier should be in now. Yep, they're all in now. Okay, very good. But is that okay? Does am I mm-hmm, mm-hmm, in the difference? In the difference, it has to be in X but not in Y. That is correct. Okay, so I think this is a good time to switch mode to use examples. Okay, so let's do that. So let me switch to, oh, I cannot do that just yet because I haven't talked about how a set is represented or how we can say, oh, this set here has these elements in it. So we have to, so I'm going to have to skip forward a little bit. So we're going to leave a bookmark about here, but I'm going to skip over a little bit forward to basically say, what does it mean? How do we express that a set has a um, certain members in it? So that's basically what this part is about. Okay, how do we describe the membership of a set that has a finite number of members? Okay. In other words, who is in this particular set or what is in this particular set? How do we enumerate and go like, okay, these things, they're all elements of this particular set. So that's what this bullet point is about. So, I did kind of make it a little bit more complicated than it needs to because, I was using BNF. Okay. So basically, okay, let me just kind of fast forward to, this is a set with three elements. A, B, and C are the elements of this particular set. So if you want to ignore all the BNF stuff, which is You can, okay, it's not a big deal. But BNF, which is Becker's nor form, is a way to specify syntax. It is basically a meta syntax. And how many people in this class have heard about meta syntax, which is basically the syntax to describe syntax itself? So a few people raised their hand. Okay, very good. Because eventually it will become useful. Okay, every time you want to learn a new programming language, you need to. Okay, there are two ways to learn a new programming language. You can go by examples. Okay, I'm just going to read a bunch of examples of your programs written in this particular programming language, and I'll extract the pattern out. Okay, that's one way to learn a programming language. That way of learning a programming language can be intuitive. Okay, it's easier for some people, but you're never really 100% sure about what the rules actually are because you're only generalizing from a finite number of examples. The other way to learn a new programming language is to look at the syntactical description of the programming language. Now, is it going to be easy? No, it's not easy, okay, because you kind of have to learn how to read PNF and all the other stuff. But the good thing about learning it this way is you're learning the actual rules first, and then you're applying those rules as you start to write some code. So when you have an error, like a compilation error, the program doesn't work, it's easier for you to diagnose. It's like, okay, right, I forgot about this particular rule, but you already understood the rule, you just forgot it. Okay, but in the other way, when you're trying to generalize from reading a bunch of sample programs and your program doesn't work or it doesn't compile, now you're going to be left scratching your head because you never really learned what the rules are supposed to be. Forgetting a particular rule is different from not knowing the rule to begin with. Okay, so that's a little spiel of why BNF is important if computer science is what you want to pursue as your choice of career. So anyway, in this case, the notation is you have to use braces. If you use parentheses, I will take points off. If you use brackets, which are the rectangular ones, I will take points off because in mathematical notation, braces, or most people say curly braces, are the ones that you need to use to enclose a list of elements in it. So in this case, this particular set where the mouse cursor is has exactly these three elements, A, B, and C in lowercase. Think of it as you have a folder that has a file called A and a file called B and a file called C and no other files in that folder. Is that okay? So let me ask you another question. Are files inside a folder intrinsically ordered? Nope, because when you go through a file explorer, you can say sort by last modification date. Then the files will be listed in a particular order. You can also say sort by extension, sort by file name, sort by who accessed it last, and so on and so forth. Kind of depends on the operating system. But there are many different ways to quote unquote sort how the content in a folder is displayed. There's no intrinsic ordering within the files of a folder. In other words, the only question you really can ask is not, is this file before the other one? You cannot ask that question. But you can ask, is this file in that folder or not? You can ask that question. That's a valid question to ask. Is that okay? And it's the same thing with a set. So if I write the set content or membership this way, it's the same as this particular set, which is the same as this one, this one, this one, and this one, because they all list exactly the same three members within the set. The ordering does not matter. Are we getting that? Okay, because that is important. Okay, all right. And this is the notation of an empty set. Well, can a set really be empty? Well, then the question you have to ask is, can a folder be empty? Well, when you first create a folder, it is empty to begin with. Okay, so a folder can be empty, a set can be empty as well. All right, so now we're going to go through some examples. And I intend to capture all these examples and kind of put it into the notes here. So, your focus, probably should be on the discussion, on the concepts and your understanding of the concepts, and not so much on, trying to frantically copy everything that we have here. All right. So we'll go start with a few examples. We'll start with something that is relatively simple. This tool is called Joplin, and some of you already know what is Obsidian for taking notes. Joplin is kind of like Obsidian, except this one is actually totally free. Okay, so you can just download it, run it on your operating system. On the left-hand side, I'm going to type everything in Markdown, which is a markup language. Okay, so Markdown is kind of a play of the nature of Markdown as a markup language. On the right hand side is the rendered Markdown notation. So you probably want to focus more on the right hand side, unless you're also trying to learn Markdown at the same time. So that choice is up to you. All right. So I am just going to use a few equations here. So we'll start with a set. Let's say we have ABC in it. And we'll start with intersection, okay? So we'll start with intersection, which is a cap, and then it is intersecting with another set, which I intentionally kind of scatter the characters around a little bit here, okay? There we go. So the question now is, what is the answer? So give me all the notations also, okay? Starting with, the delimiters of the notation. Yes, it is not a Boolean operator. It returns a set. So the intersection of two sets is a set itself. And therefore we can talk about membership. That's how it is defined. Yep, yep, that is correct. Okay. So we're gonna use so this is the way I usually type things is I begin and then I immediately close it and then go back and type the content. So just to make it a little bit more confusing, I'm gonna say CA because ordering is not important. Okay. Yes. Oh, say that again. How do we color things? And then the curly brace again for the things that is being highlighted. Okay. Does it work inside the equation? Okay. All right. So in the future, I'll do that. But I think it's easy enough for you guys to differentiate between A, B, C, and D. I hope so. Okay. Because after all, no editor that I know of would highlight each and every variable name differently because your eyes cannot actually differentiate between that many colors. All right. So, do we have any questions about this one? Yes, because okay, so let's go back to the definition, okay? Because that's a good question, and the best way is to look back in the definition itself. An element, a value, can be in the intersection of two sets if and only if it can be found in the left-hand one and it can be found on the right-hand one. So it has to be found in both. So when we go back to the example here, A can be found, okay, this A here can be found on the left-hand side as well as the right-hand side. C can also be found on the right-hand side and the left-hand side. B can only be found on one side but not the other one, so it is not in the intersection. And then D can only be found on the right-hand side but not the left-hand side, and therefore it is also not in the intersection. Yep. Conjunction is and then disjunction is or. Yes. So the way you can more quickly remember which one is about conjunction and which one is about disjunction is to see which end the symbol opens. Both and intersection opens at the bottom, and both or, which is kind of like the V symbol, and union open on the top. So that's one way to quickly remember how they are associated. Okay. So that's good. And then we look at another example. So lazy as I am, copy and paste, and then change one letter here. And then I'll let you guys try to tell me what is the membership of the union of the same two sets. Yep, go ahead. Okay. I was actually trying to address the person next to you because you get to answer all the questions. I want somebody else to have a chance. Okay, that's okay. The correct answer is yes. A, B, C, and D are all members of the union of these two sets. So I'm gonna kind of sprinkle the letters all around B, D, C, A. It doesn't matter, okay? I just want to really emphasize there's no intrinsic ordering within the set. That's basically why I kind of scatter, the membership all over the place because it really does not matter. This helps to emphasize that there's no intrinsic ordering. Are we good so far? Good. All right. And then let's take a look at the next one. Okay, the difference. Okay, so go here, and this time we do a minus. Okay, and then you guys tell me what is the result. Go ahead. It is just B. That is correct. Okay, it is B alone because B is on the left-hand side, but not on the right-hand side. What about A? A is on the left-hand side, but it's also on the right-hand side. It doesn't meet the requirement to be a member of the difference. What about C? Yeah, same thing. C is on the left-hand side, but it is also on the right-hand side. It does not meet the requirement to be in the difference. Are we good so far? All right. Any questions that you need to ask? Yes. Cartesian product? Oh, it's going to be useful. Cartesian product is the foundation of functions and also relations. So those are two kind of big topics that we're going to have to go over. So yes, Cartesian product is an important topic. It's really easy to understand too. It's kind of like, it's really kind of like the Cartesian coordinate system where one axis is specified by one set, the other axis is specified quote unquote the other set. Now it's not a very really accurate description because when we talk about an axis, there's an intrinsic order, right? This value is before that one, this value is before that one. But when we talk about a set, there's no such thing as ordering. But from the visual perspective, it kind of helps people to understand. Oh, so it's basically spanning. Okay, if you have taken linear algebra, we are basically spanning a space by taking two base vectors. But it's also a little bit different from that because you can take the same set and it spans, a space. It's not just a line. So when we get to the definition, we'll talk about it. Yes. Mm, I would not do that, because they are not related in that way. But I can see why you said that because it has to do with conjunction versus disjunction. But the expression of all the things that you are ending and all the things that you're oring does not make sense in this particular case. So I would not make that association between the quantifiers and how intersection and union are defined. Hmm. Yep. You can still read that one. You can still read that one, but I do expect you to understand this one. So there's a difference between how you get the information and what you can understand, you know, afterwards. Alrighty. Um, okay, so we are almost running out of time. We are currently still talking about the subtraction, which is, the difference. So I'm gonna stop the lecture material here so that I can, take roll. So the road taking activity is already up. You cannot see it just yet. Okay, now you can see it. Just refresh your browser and you should be able to see it. And as usual, it will ask you for a word. And the word for today is definitive. So definitive. Definitive. Okay. So please go to Canvas and participate in the role taking activity. And by the way, I will drop people who have not turned in any evidence that they are also enrolled in CISP 430 as of noon, because that's when the due date is for that activity. So if you think, but that's not fair, but because I am taking 430 or I will be taking 430 or I have taken 430, you know, well, come to me and I'll add you back to the class, but I will drop you first. And I can see some people who have not turned in anything for their activity was not paying attention. Yes, I know who you are. That means, people who have still have a dash with this activity or have not submitted anything for me to grade in this activity and had a dash to begin with, those people will be dropped. Okay, so talk to me to get a permission number once you give me that evidence. Yes. Huh? If you have already taken 430, you would have a 1/1 already because I would have just go like, okay, you don't have to submit anything. So you'll be fine. There's nothing you have to turn in. So this what I just said only applies to people who one have a dash over one, which means they don't have a score yet, and two have not submitted anything for me to grade. Those people will be dropped. All right. Well, we only got about 2 minutes left. I'm not going to introduce any additional topics. Okay. So I hope you guys, are okay with the flow of the class at this point. Okay. If you're thinking it's moving a little too fast, just let me know. You can send me an email, talk to me in the office hour, and stuff like that. Um, and I'll see you on Wednesday. Okay. Wednesday is our second class. Uh huh. Sorry.